Good evening. All right. This is kind of an ambitious lesson, and I'm going to try to keep it really short. So first of all, you did not accidentally miss 9.7. 9.7 is a section on constructions, and we're going to come back to it after the fact. Constructions are kind of a very ancient way to look at geometry, where we use exactly two very simple tools. One is a compass, basically one of those things that kind of opens and closes and draws circles, and the other is a straight edge. It does not need to be a ruler, doesn't have to have any markings, it just has to be a perfectly straight edge and a compass. And we're going to learn how to do different things like divide things in half and divide angles and make perpendicular bisectors and so on. But for the purposes of the Chapter 9 test, we're going to focus just on the last three lessons. And like I said, we'll come back to 9.7. And so the last three lessons, 9.8, 9.9, 9.10, they're actually broken up into individual lessons, but they basically all have a common theme. And that common theme is they're all going to involve transformations. And all a transformation is in geometry is where we take one thing and we change it. We may move it, we may slide it, maybe we may reflect it, we may rotate it, we may shrink it and make it smaller, we may expand it and make it bigger. We may do some combination of all those things where we rotate it, flip it, and expand it. We sometimes expand it proportionally so we get similar figures. Sometimes we might stretch it out horizontally but not vertically. All of those things are called transformation. So anytime we change the position or the size of a figure, it is called a transformation. Now in isometry, the second word down here is not in your book, but it's one of my favorites, and that's an E. It's not isometrics. It's isometries. And isometries are special types of transformations where essentially everything is kept the same. So figures are moved in such a way that the new figures, the images, are congruent to what we started with. And that's mostly what we're going to focus on as we're looking at transformations. Alright, so let's get right into it. Suppose I draw this figure, and I'm going to go ahead and shade the original figure. Okay, so this is the original figure I drew. Real quickly identify it, count the number of sides, and I think you'll see that it's got 5 sides, so this is actually called a pentagon. Okay, now this is a kind of a weird pentagon because it is concave or non-convex because it's got that dent in it. All right, so let's take a look at the two other pentagons. First of all, this is called a pre-image. Okay, it's called a pre-image because it's what we start with. It's before we do any transformations. And so the pentagon pre-image is the blue shaded one. All right, first I want you to take a look at what has happened to move the blue one to this one. Okay, and I think if you look at it closely, you can see that essentially if we take the blue pentagon, the pre-image, and we slide it over just a little bit up and to the right, sure enough, we will get this red shaded pentagon, okay, that is exactly the same size and shape as the original. Okay, now this motion right here, you might call it a slide, okay, but the fancy name for it is a translation. Okay, that's a fancy math name to basically just say you take a figure and you just slide it across. Now, if you slide something, you don't make it bigger or smaller, you don't flip it, you don't do anything weird with it. So obviously the image, which is what this is called, is going to be congruent to the pre-image. Okay, and it lines up almost perfectly, or actually exactly perfectly. So if I call this point down here A, the new point is going to be A prime, meaning it's where A moved to. And that way we can keep track of all the points. So this is B, C, D. And I guess I got to come back and I got to go E. So this is actually, sorry, I kind of went out of order here. So this would be pentagon. We have to go in order when we name it. So it'd be A, E, B, C, D. And it would go to A prime, E prime, B prime, C prime is up here, and then this right here would be D prime. Okay? Now, another motion I can try, it's very similar, and it's called a rotation. So if I take this original figure here in blue and I rotate it around like so, I can see that I get another congruent pentagon, and this one I have gotten to not by sliding but by rotating the original figure. In the center of the rotation would probably be down here somewhere, and then I rotate everything kind of clockwise. Okay, now the rotation might be just a little bit harder to see, but it is, the fancy name for it, is a rotation, okay? And that's, the ordinary name would probably be something like a turn, okay? And I want you to notice that in both of these, that the image, and I'll go ahead and color this one in yellow, the image, the one I end up with, is exactly the same size and shape as the one I started with. And again, I could relabel this one. Since I already have an A prime, E prime, B prime, C prime, I could use double primes for this one. And you can see that A would end up here. And I'm not going to go all the way around it, but you get the idea. Okay, now the next one, there are three of these major motions. There's the translation or the slide. There's a rotation. And then there's another one. And the other one is a reflection. So I'm going to use a big capital R instead of a geometric object here. And when we draw a rotation, what we're going to do, or I'm sorry, a reflection, what we're going to do is we're going to have a line of reflection. This is like a mirror image. Okay, and so what we're going to do is we're going to reflect across this line in such a way that it's perpendicular to the line. Okay, so this will be the new point that'll be kind of at the foot of the R, and then we'll go across, and again we'll get another line here. I'll take a point here and I'll go across perpendicular to the line and an equal distance the other side, and I get a point right about here. And then you just kind of connect up these points. Okay, and so you end up with something that looks kind of like this. Okay, and that's not perfect, but if you do this really accurately, you can get a much better mirror image. And so, let's see, it actually looks more like this. There we go. Okay, that'll help a little bit. Okay, and again, this would be called a flip, would be kind of the ordinary name for it. The fancy math name for it is a reflection. Okay, and so those are your three basic motions. Okay, let's go ahead. An isometry is a transformation that preserves congruence. Sorry, my stylus is not cooperating today. Preserves congruence. Okay, and so again, the three major categories are or types are the translation. Okay, and again, that's basically just a slide. Okay, there's the rotation, which is a turn, and then there's the last one where we do a mirror image across a line, and that is called a reflection. Okay, and we can think of that as a flip. Okay, now the notations for these: the translation is usually a capital T. A rotation is a capital R, and a reflection, since we've already used one R, a reflection will be a small r. Okay? All right, let's go back to this image right here. Okay, here's another thing we do with reflections. I can draw half of an image, and then what we can try to do is we can try to draw the other mirror image. Okay, and so for this one, it looks kind of like a weird little Christmas tree here. Okay, and again, we're just going kind of perpendicular to the line and an equal distance to the other side. Okay? And so, in some of this you can freehand, and some of this you're going to want to actually do the points, and there you go. And so, again, that's not perfect, but that's the basic idea of doing a mirror image. Now, if I started with this side over here being the pre-image, then over here this would be the image. But if I start with the right side, I could always reflect back to the left side. And again, reflections are isometries because they preserve both congruence. They produce, in other words, they preserve both size and shape. Okay. Now, if we have a figure like this tree with both halves, where we can draw a line right down the middle of it, and both sides are mirror images of each other, then we say it has reflection symmetry. Okay. We can also do very specific things where we measure angles of rotation, and we actually measure the amount of slide. But for our purposes, this is going to be enough to get us started. So we're about 8.5 minutes in, so I'm going to cut this short. And again, what we're going to wrap up in class tomorrow is we're going to talk about these three transformations in a little bit more detail, and we're going to do some practice problems. So be thinking about translations, rotations, and reflections, and just the general idea of a transformation, and these specific transformations that I just listed that are isometries. We'll talk a little bit about symmetry, and we'll wrap up this chapter so that we can start reviewing and get ready for a test at the end of the week. All right, well, thanks for watching, and have a great night, and I'll see you tomorrow in class.